Last class we have discussed about STP, right? State protocol. Eliminate single point of failure. We require backup links. Once you provide the backup links, so this type of topology we call redundancy topology. The good thing redundancy topology is a backup is available, right? The thing is, once you provide the backup links, continuous broadcast, the loops are being forming. So how to stop the loops? So to stop the loops, we used to configure protocol is what? Right? Hello? Right. So spanning tree protocol is to avoid layer 2 switching loop by blocking a port. To block the port, STP protocol will do selection process based upon the root switch, like a root port, designated port, non-designated port. Right? So I given already one task to you, right? Based upon this task, have you done your task? Did you find out which is the root switch here? Switch A, switch B, C, D. Out of 4 switches, which is the root switch? So what is root switch? Root switch means best switch ID. Switch ID is a priority plus MAC address. Okay. Now, first let me say priority value 32768, 32768, 32768, 32768. Like all the priorities are same, right? Like all switches, priorities are same. Then, which is the root switch? If priority is the same, now STP protocol will consider MAC address. Let me see the MAC address. So how to find out which is the lowest MAC address means? So first digit, like first character, you have to start from 0 for A, for B 0, for C 0, for D also first one is what 0, same. Second character 0 here, B, A. A means what? It's a 10. So compared to A, B is the highest. So B is not a root switch. Now compared to C, C is a 0. Okay. Now I'll go for D. D is 1. Compared to A and C, D has the highest 1, right? So D is also not a root space. The election between the A and C. Root switch elections. Here 00C, C also 00C. Here is a 4 and is a A is what 10. So which is the lowest? Lowest is a switch A, right? 4. So switch A is a root switch. Switch B is non-root. C is a non-root. D is also non-root. Root switch elections is being done. Now next selection process is what? Root ports. Every non-root switch must have a one root port, right? So means B must have a one root port. So switch D should have a one root port, and C also should have a one root port. In B, it can be 24 or 23, right? So which is the closest to switch A? Which is the nearest to switch A? There is a root port. If traffic is going via port number 24, cost is 19. If traffic is going via B to D, D to C, C to A, it's a highest, right? So port number 24 of switch B is a root port. Port number 24 of switch C is also a root port. The switch D, if traffic is going via 23, no, so 22 port. 22 to 23, 23 to A. 19 plus 19. If traffic is going via 23, what's the cost value? 19 plus 19, same. So when cost is same, what STP will do? Will consider neighbor switch ID. For port number 22, which is the neighbor switch. For port number 22, which is the neighbor switch, guys? Switch C is the neighbor. So switch C MAC address is 00C. For port number 23, which is the neighbor switch? C is the neighbor, right? So switch B MAC address is 0A07, which is a lowest MAC address via 22 or via 23? Via 22. So port number 22 is the closest, like port number 22 is a root port. Now, root port elections is being done, designated ports. So designated ports are very easy, right? Like opposite of root ports are designated ports. Root port opposite 22 is a root port. Root port quite opposite what? Designated port. Root port opposite is a A24 is what? Designated port. Now C23 also designated port. Like all root ports and all designated ports are forward stage. So finally now election between switch B23 and D23, right? B23 and D23. Out of two, which is the root switch? B23 or D23? Like how to calculate this is now we need to understand if one device is connected in the middle. So from this device, data traffic to reach a root switch, how many routes are available? Via 23, B23 to A can reach, right? It means 19 plus 19. If traffic is going via D, 19 plus 19 plus 19 total. It's the lowest cost that is a designated. It's a designated port, and D23 is a non-designated port. So finally, escape will block which port, guys? D23 is being blocked, right? Clear? Any doubts? Which D? 23 is A. Wait a minute. So this is the topic yesterday we have discussed, right? Can you tell me, guys, do you have any drawbacks of STP protocol? Today we have started very good scenario, like two switches, A, B, single link. If the fails, no backup. Backup link is being started. Loops are being formed. To stop the loops, STP protocol is required. So how STP is going to block the port by election process? Like one by one election, clearly we have discussed one by one. So finally we got one idea. And STP states also. So how STP is going to do the states like a block state, listening state, learning state, and the forwarding state. So each state, how much time is taking. Now we have a clear idea about STP protocol function action, right? From the yesterday discussions, do you think you have any disadvantage of STP protocol? Any drawback? Let me take one switch, connecting some user devices. Device 1, device 2, 3, 4. You see here, I'm connecting a cable PC to switch. They concentrate in the switch port color. LED port color is what? Orange color, right? But why it is not coming the green? It may take time, right? Why? So once you connect the cable, your ports is going for listening state and learning state. You can clearly check here. So spanning tree. So listening state has already been finished. Now port number 1, port number 2 in the which state is what? Learning. Still one is in the learning and one is in forwarding. Now both are green. Check here, forward state. So what is mean here? Each and every port of the Cisco switch is waiting up to 50 seconds before your data is being transmitted. Like switch port don't know about your which port, which device has been connected, right? You're just connecting a one cable. Now how my switch port will come to know this device is a switch or this device end user device? know this is a PC. But how my switch port will come to know this device is a PC? How the switch will come to know if another switch has been connected? So switch to switch link is connected. Now how this switch will come to know port number 4 switch is connected. Port number 3 PC is connected. Port number 2 PC is connected. Port number 1 is also PC is connected, right? Like how switch port will come to know like which ports, which device are connected based on BPDU packets. BPDU packets, right? Like BPD packets can exchange for every 2 seconds in a which devices switches can generate, right? Like here, end users can send the BPD packets. Your PC can send the BPD packets, guys. No. So what switch ports are doing is, so all 1, 2, 3 ports are wait up to 20 seconds. Like up to 20 seconds, if there is no BPD package, now it's going for learning state and listening state. Listening state and what? Learning state. So still no BPD package, then what 1, 2, 3 ports can understand, okay, so this is not a switch. These all are end user devices. Why? Because it's been 50 seconds. So still I'm not getting any BPD packets means these all are end user devices. But once they connected to here, switch to switch is connected. Have removed the link between the switch to switch. Again, have connected, reconnected. Now see, color is what? Amber and the orange color, right? So switch A and switch B both are waiting for BPD packets. Like after 50 seconds, I mean listening state and learning state, within 50 seconds they are exchanging what? BPD packets. Like by exchanging BPD packets, A will come to know, okay, port number 4 I am receiving the BPD packets means port number 4 switch is connected. So how much time will take to switch which device is being connected? Which port we can come to know after 50 seconds. Like after 50 seconds, now switch will forward the data traffic. Like up to 50 seconds, switch is going to waiting and switch ports are going to listening state. Switch ports are going to learning state. In the single point, simply I can say each port waits up to 50 seconds before your data is being transmitted. See now, I'm connecting one new device, user device to switch. Now port number 5 is connected. Now switch directly forward the traffic. Port number 5 directly forward the traffic. No. What port number 5 will do? Go for listening state and learning state, right? When you can check, now port number 5 is in learning state. Still port number 5 in L or N, learning state, right? So still it is in a learning state. Now it's become what? Forward state. Forward state, right? So this delay, this 50 seconds time delay will cause some problems in application. Example, I connected one DHCP server. DHCP server in my network. Actually, DHCP server rule is what? So DHCP has to provide IP address to all end user devices, right? Now I connected one DHCP server here. Now port number 6 DHCP server is connected. So port number 6 can be responded how much time? So up to 50 seconds can receive the IP addresses for the end user devices. So each port waits up to 50 seconds. So this delay can be causes some problems like application problems, like a DNS problem, DHCP problems. These are drawback of STP protocol. So spanning tree protocol is running by default on all the ports of the switch. Makes spanning tree protocol makes what? Each port up to 50 seconds before data is being transmitted. This delay can cause some problems like DNS, DHCP problem. Then how to solve it? There's a problem with the STP protocol. Like how to fix the problem means we have one good option in the Cisco devices. So that is port fast. So to solve the above issue, port fast can be implemented on Cisco switches. Have the what? Port fast option is there. By default, STP is enabled in all ports, right? 24. In the switch B also, by default, STP is enabled in Cisco switch. Now for port number to have one device is connected, now port number 2 will wait how many seconds? 50 seconds. Like after 50 seconds, now port number 2 will come to know, okay, port number 2 switch is not connected. For port number 2, end user device is connected. Why? Because I'm not receiving any PPD packet. Port number 3 have connected one device. Like what port number 3 will do? Will wait for 50 seconds. So each port waiting 50 seconds before data is being transmitted. What I'm doing is, if I connect a switch to switch link, now switch A users, B user also can communicate. How much time will take? 50 seconds, right? So they have to wait for 20 seconds and listening state and learning state. PPT packs have been exchanged. So to solve the above issue, we have good option is what port fast. What exactly port fast is doing is port fast is going to skipping listening state and learning state. So don't wait for 50 seconds. Once your end user device is connected, directly forward state. Forward state. Like how exactly Podfast is working here means, so Podfast is going to skipping listening state and learning state. I repeat once again. So what exactly Podfast is doing here? So Podfast is going to bypass the election process, bypass the listening and learning states, skipping it. So directly one device connected forward state. No, don't wait for MAC address, don't wait for priority value, that's it. So just simply skip it. Means if we configure port fast, we are going to disable STP. STP is being disabled on the selected port. Okay, right. So switch A and switch B, only one link is connected. If it's a fails, no communication. So for the backup purpose, I'm connecting one more link. The redundancy. Any one of port is what? Block port. Now the problem is to make my switch ports are faster, then what I have doing is in switch A, all the ports are configured port fast. In switch B also all the ports are configured port fast. What port fast will do, guys? So what exactly port fast is doing is going to skip the listening state and learning state. So once skipping the listening and learning state means we have removed STP protocol. If we remove STP protocol, what happened? very important point is port fast is only recommended to configure on where your end user devices are connected. If you configure port fast between the switch to switch links, loops will be formed. Yeah, guys. So port fast is only recommended to configure where your single device, single PC, like an end user device are connected. If you configure port fast between the switch to switch, again what happened? Loops will be formed. It's a very important point you need to keep in mind when you are live environment. Port fast. See the point here, third point. Port fast is recommended to be enabled on port where end user device is connected. So what happened? Port fast feature can be enabled on port where there is no bridges and switches connected. Otherwise, what happened? It may create loops. Show you how to configure. Space fast Ethernet. Three. Port number 5 only port fast is being configured. What I'm doing is have remove the cable. Let me take one new device. Port number 5 is new cable. Yeah. Maybe already some device. So one new device I'm trying to connect it to port number 5. From PC to port number 5, you concentrate on the LED status. See, directly it is what? Green. But if we connect the remote port number 2 and connect, I'm reconnecting to port number 1, port number 2 also. Amber colors. Currently. So port number 5 only have configured what? Port fast. So we can configure port fast for a single interface or I can configure port fast for all interfaces also. Configuration. For all interfaces, in configuration mode, global configuration mode, spanning tree port fast default is the command. For each interface, for an interface FA 0/example 5, spanning tree port fast. Like is it clear, guys? So these are about SAP protocol. Now today, let me see one more scenario. See, the scenario is here. Hello, can you hear me, guys? New scenario, try to understand clearly. Goes on it. First switch A, switch name is A, host name, and next one is a switch B. Switch A, port number 1, port number 2, 3, 4. They have some devices are connected. Okay. Switch B also one end user device is connected. Now link between switch A and switch B have connected one cross cable. If switch A ports are fast Ethernet ports, and switch B ports also fast Ethernet ports. Now what will be the link speed? Switch A and switch B users. So this user and this user, data transmission happen with how much speed? Let's say 100 Mbps, right? Okay. Now between the A and B switch have only one link. If it's a fails, no communication. Single point of failure. So to eliminate single point of failure, we required what? Backup link. Like I'm taking the one more backup link from port number 2 to port number 2. So for what will be the second link speed? Second link speed is also what? 100 Mbps, right? when you have a multiple links, loops are been forming all of the forwarding state. Like to stop the loops, we used to configure protocol is what? So once STP is enabled, what STP is going to do is going to block the port to avoid the loops. Consider port number 2 is being blocked by STP protocol. So port number 2 is a blocking means A user and B user can communicate via which link, guys? Via which link? First link. How much speed? 100 Mbps. Okay. Like after some time, your first link is being failed. So what STP is doing is automatically your block port will become what? Forward state. First link is being failed. Now A and B users can communicate via which link now? Second link. How much speed? 100 Mbps. Even after some time, if second link is also been failed, now how A and B can communicate? No communication. So what I'm doing is based upon my number of failure chances, we can make number of backup link actually. So let me make one more backup link from port number 3 to port number 3. So what is the third link speed? 100 Mbps. Now what STP is doing is to avoid the loops is going to block port number 2 and as well as what? Port number 3. Two block ports. Now A and B users can communicate via first link with 100 Mbps. If first link is being failed, out of two block ports, any one can be forward state. Like port number 2 is being forwarded. How much speed they can communicate? Only 100 Mbps. It also fails. Again, block port become what? Forwarding state. Actually, between the A and B switches have with three links, even you can make use only one link, right? Means we can use only 100 Mbps. Then how we can data transmission more than 100 Mbps? So to forward the more than 100 Mbps means now we have to change your devices, right? So we have to change your devices and purchase one new devices which is supporting for all ports or gigabit ports or 10 gig ports. Then you can increase the speed. Not like that. So what I'm doing is I'm going to configure one protocol called Etherchannel. Once we configure Etherchannel, what exactly Etherchannel is doing is Etherchannel is going to combine Etherchannel is combine multiple physical links into one logical link. Etherchannel or port channel is going to combine multiple physical links into what? One logical link. So switch A uses data traffic and transmission with now like how many links are being binded here? Three links means we can utilize how much speed, guys? 300 Mbps is been utilized. We're combining multiple physical links into one logical link. Here, the first advantage of Ether channel is how much bandwidth is available, like full bandwidth utilization. We can utilize the full bandwidth. Have the four links between the A to B, like four links bandwidth you can make use. The second point is now your data traffic is not going to only one link or second link or third link. Your traffic is going via three links. Traffic can go via what? Three links. This is load balancing. So the first advantage of Ether channel is a full bandwidth achievement, full bandwidth utilization. The second point is a load balancing. Now out of three links, any one link is being down. Now how much speed they can communicate? 200 Mbps, right? So means we have what? Redundancy also available. The very good advantage of protocol actually. Ether channel can support providing what? To utilize the full bandwidth, load balancing, at the same time redundancy also will available. So generally, Ether channel we used to configure between switch to switch. Not only switch to switch, we can configure Ether channel between the switch to router also. For example, have a one router. From switch to router, have one link is connected. Router port is a fast Ethernet. All the traffic, all induces traffic can reach to router with how much speed? 100 Mbps only, right? What I'm doing is I'm connecting one more link to my router, fast Ethernet 0/1. Now if I configure Ether channel, what Ether channel is doing is it's going to combine two physical links into one logical links. Now all my end users devices can forward the traffic to router with how much speed, guys? Now 200 Mbps. But in the real time, generally people will connect switch to router with gigabit 0/1, gigabit 0/0. Now, if we combine the two physical links into one logical link, how much speed you can transmit in the data? 2000 Mbps, right? So like this, load balancing. So not only switch to router, even switch to firewall also can count. So this concept is what? Ether channel. What Ether channel will do? Ether channel combines two or more physical links into one logical link. The main purpose of Ether channel: achieve full bandwidth, load balancing, and redundancy. Ether channel can be configured between which devices? It can support only for switch to switch. Can support for what? Router and firewall. Like in our example, how many links are binded here? One, two, three links, right? But Ether channel can also support to combine one, two, four links, or five links, or six links, or seven links. So maximum Ether channel can combine up to eight links only, eight interfaces. Ether channel can consist of up to how many interfaces? Eh? A very important point is here to create Ether channel. Switch ports needs, you know what? To create Ether channel, if switch A ports is a fast Ethernet ports, switch B also should be is what? Fast Ethernet. Means A and B switches between speed had to match. And port number 123 ports on A is configured with a half duplex communication. Switch B 123 ports also should be configured what? Half duplex communication. Either half, either full. That means duplex should match. If port number 123 in the A switch is a access mode, so switch B 123 ports are should is what? Access mode or trunk mode. Either access, either trunk. So these should match Ether channels, same physical ports, same speed, duplex. Either port should be access or either port should be trunk. A native VLAN, which is local VLAN and allowed VLAN. Do you remember DTP protocol? Dynamic trunking protocol. What is the responsibility of running the DTP protocol? What DTP protocol will do? The use of it. DTP protocol is a responsibility of dynamically negotiate between the switches, right? Between the two switches, we want to enable trunk. One side, if you want to trunk, other side automatically trunk will be formed. The short form you can say DTP protocol is what? Automatic trunk between the switches, two switches. So how it works? It has two modes. No, DTP protocol is not for different network communication, different VLAN communication. DTP protocol for what? Dynamic trunking protocol means automatic trunking protocol. Between the switch to switch, two sides no need to configure. Only one side if you configure trunk, other side automatically will be formed trunk, right? We have seen some combinations: dynamic desirable and dynamic auto, dynamic desirable active initiate, dynamic is rapidly waiting. Right? This is a DTP protocol. Similarly, ether channel also we have a two categories. Ether channel also have two categories. One is a static ether channel. Static means in the switch A and switch B manually you need to configure ether channel. If switch A is a Cisco switch, if switch B is a Cisco switch, between the Cisco to Cisco switch has have one dynamic ether channel. That protocol is PAGP, port aggregation protocol. PAGP is a Cisco protocol, has a two modes. One is desirable, and one more is a auto. It's a Cisco protocol. What desirable will do? If you configure desirable, it's actively initiate negotiation other side switch to form a ether channel. If we say auto, is passively waiting to respond for the to form ether channel, right? One side is actively initiating, one side is passively waiting for that. So this protocol can work between the switches. Cisco. What about switch A is a Cisco, switch B is a non-Cisco? Still we have one more protocol which is LACP. Link Aggregation Control Protocol. So this LACP is a open standard protocol. LACP is a open standard. LACP has the two modes. One is a active mode. One more is a passive mode. Active and passive. Active is similar to desirable, and auto mode is similar to passive mode. Methods we have with the channel: static, AGP, and LACP. Port aggregation protocol, link aggregation control protocol. PAGP is a Cisco protocol, LACP is open standard. Let's see now about PAGP. It is a Cisco protocol, has two modes, desirable and auto. What desirable will do? Interface will actively ask other side switch to form ether channel. Same like a interface will passively waits. form ether channel for other side space is asking. Copy. Next protocol is LSAP, full standard 802.3a-D, the standards. Two modes, active mode and passive. Interface will actively ask other side to form ether channel, similar to desirable, and passive is waiting, passively waiting, form ether channel. The configuration, interface, our example, we combined interfaces, right? Port number one, port number two, port number. Then you can use the range command also. Interface range pass ethernet 0 slash channel protocol. If switch A and B both are Cisco switches, then use command is what? PAG. If it's a open standard protocol, is a Cisco or non-Cisco devices, then channel protocol, so PAG place, you can use the command is what? LACP. LACP modes are what? Channel group number can be any number. Mode group mode is a is of desirable. You have to write what? Active mode, and auto mode is what? Passive. If it's PAGP, same modes. Desirable and auto mode. Same configuration for PACP and LACP. LACP, the PAGP, or you can use what? LACP. If it's LACP, then desirable place use command active. In auto mode, you can use what? Which protocol had to make use, guys, here? PAZP or LACP? We are using Cisco packet software, right? Means switch A and switch B both are what? Cisco. PAGP. Channel. Group. Channel group number. Group number you can use any number between the 1 to 6. Actually, 1 to 255 can use any number. But this software, Cisco packet tracer software, can support 1 to 6 numbers. So group number 3, let me use our group number 2. Channel group number 2. What are the modes in PAGP modes? Either desirable, either auto mode, right? Desirable. The configure desirable. So let me go to other side switch. In switch B, interface range fast Ethernet 0/123 ports. Channel protocol PAGP. Channel group number. Switch A group number, switch B group number should be same. So group number 2, mode, auto mode. Now I just got a one message on log message. Interface port channel 2 change straight to up. The link is been up. It means your logical link is been up. Now see the port LEDs all are the red color, right? Now all are the orange color. Now wait for some time. Like the three links, all the ports become the green. Means they have made a one logical link. One side become the green. Other side. Can you see here? Switch A and switch B, physically there are three links, but now we have configured ether channel, right? So means three links are combined, have only one logical link. So switch A and B can understand. So A, B are connected to how many links now? Understand? They are connected with only one link. But actually, how many links is there physically? There are three links. But ether channel has been combined. If switch A and switch B fails, we are connected to three links, then only loops are being forming. Right? But now what is the feeling of switches? What switches can understand? The A and B, we are connected to only one link. So there is no multiple links here, no loops in here, right? This is the logic, main logic actually in Etherchannel. The verification command. So Etherchannel. show port channel, show the channel summary. So this is about Etherchannel. Yeah, STP automatic working. Not stopping that. Running in the back. Successfully, we have finished about our switching classes. Like complete thing is being done. Let me show you what topics are being covered in the switching. So first class we are discussed about what introduction to switch and the switch function, broadcast, unicast, and the switch configurations, manageable switch, unmanageable switch, types of categories of switches. Next, VLAN, trunk, voice VLAN, trunk, BGP, dynamic trunking. These topics have been covered. Next, yeah, VLAN, voice VLAN, trunk only in one section. The next session we have discussed about what dynamic trunking protocol, VLAN trunking protocol, inter VLAN routing, TDP, LLDP, STP, port path, Etherchannel. Any doubts, guys, regarding this topic? Yeah, hexadecimal numbers are being fixed, right? Hmm. MAC address is a hexadecimal. Hexa means 6. Decimal is what? Uh, Hexa is what? 6 and decimal is 5. First, we'll see the decimal number. Decimal numbers are what? 0, 1, 2, 3, 7, 8, 9. 0 to 9 means what? 10 numbers. Decimal number. After 10, 11, 12, 13, 14, 15. So 10 indicates A, it's B, it's C, it's D, it's E, it's F. So indicates what? 10. Indicates what? 11. Right. Do you have any doubts regarding this topic? So we have finished about switching classes. From Monday onwards, let me start with some security related topics and internet services, internet protocol. So today I'm going to give some tasks to you. That's the reason I'm going to. Your task is try to copy it, all of you. This is your task. Take one switch for port number 1. Connect one device, and port number 4. Connect one more device, and take one router. So this router should be connected to for port number 2 one link from FP0/0, and one more link to port number 3 from fast Ethernet 0/1. And configure port number 1 in a VLAN 10, and configure port number 4 is in a VLAN 48. This is task number 1. So finally VLAN 10 and VLAN 20 should communicate. And let me tell the IPs of VLAN 10 and VLAN 20 also. VLAN 10 IP address should be in 192.168.1.0 network. VLAN 20 192.168 in the 2.0 network. Okay, guys. Now task number 2. Take one switch. More switch. Two switches. In switch A, for port number 1, connect one device. In switch B, port number 2, connect one more device. Switch A, port number 1, PC1, configure the VLAN 10. In switch B, we one device connect configure to VLAN 1. And port number 24 of A, port number 24 of B, connect one cross cable. 24 to 24. How to enable communication from VLAN 10 to VLAN 20? We require router, right? Take only one router. So this router connect on a switch A with only one interface. Example, port number 3. So by using this router, we have to allow communication from VLAN 10 to VLAN 20. This is the second task. Okay, guys. See, inter-VLAN routing or same network or different network means different network only. Task 2, VLAN 10 IP address, example 10.0.0.0 network, and V20 network is 9.0.0.0 network. This is the task. Clear? The two tasks is your task for today, and Monday, so freshly we'll start our security and internet related topic. So tomorrow is off, Sunday is off. Clear, all of you? Okay, any more doubts? Yeah, Mustafa, tell me about STP election. What does what that? Right. This is your network topology, right? Here, A, B, C, D. Four switches. Out of four switches, which is a root switch? So first election process based on what? A root switch. Next is a root port. Next is designated port and non-designated. So Mustafa here, first one is a root switch. Root switch means priority, lowest priority. So let me go for priority. Switch A priority is 32768. Switch B also same. Switch C also same. And D also same. When priority is the same, now what STP will consider MAC address. So here MAC address, switch A MAC address is a first character is a 0. And switch B first character is also 0. C 0, 3 0. Same, right? Now I'll go for second character. Hexadecimal numbers. Here 0. It is a A. A value is what? 10. So compared to 0 and 10, 0 is the lowest, right? Means which B cannot be a root switch. Now D is a 1. So D also cannot be a root switch. Why? Because A and C is a 0, is there, lowest. So compared to A and C, 0, 0, C here, 0, 0, C here. Again, one more character is a 4 and it's a A. A again is what? 10. So which is the lowest? 4 is the lowest. Means which A is a root switch. Which A is what? Root. What about switch B? Remaining, other remaining all are non-root. The non-root, non-root, non-root switches. Second election process is based upon what? Root port. Every non-root switch must have a one root port. So switch B must have one port, either 24, either 23. We have a one port, either 22 or 23, right? Same like C has a one. Which is a root port means which port is closest to root switch. In B, 24 is the closest, 23 is the closest. The closest, Mustafa. Like if via 24, we go here, 19 is the cost. Via 23, D to D, D to C, C to A. 24 is the closest means 24 is a root port. Now what about C? In switch C, we must have a one root port. Either 24 or 23. Which is the closest? 24 root port. Now in the switch D. The switch D, if we go via 22, 22C, C to A, 19 plus 19. If we go via 23, 23 to B, B to A, 19 plus 19. Cost is same. When cost is same, now STP can consider neighbor switch ID. 22 neighbor is a 00C. 23 neighbor is a 0A07, which is the lowest. 00C means via 23. Sorry, via 22. 22 is a root 4. Now root corrections is done. Designate ports. Opposite of root ports are designated ports. 24 is a root port. So this quite opposite was A24. A24 is a root. C24 root port. C24 is a root port. Opposite what? 22 is a designated port. D22 is a root port. Opposite is C23 is a designated port. So root port designated port actions is done. The finally election between B23, D23. In the middle, you have one device. This data traffic to reach a root switch via 23, B23, 19 plus 19. Via D23, 19, 19, 19. Lowest is B23. B23 is designated port. D23 is a non-designated port, which is blocked. Okay, clear, Mustafa? 19 cost is a fast Ethernet port. Fast Ethernet cost is 19. For Ethernet cost is, have standard cost values, right? Ethernet cost is 100. Fast Ethernet. As per IEEE standards, cost values are fixed. Fast Ethernet is 19. Cost is fixed. Yeah, Sunish, not only you, let me explain for everyone. First time we have is 30 or on the same website. If you go to theology.com, the last page of that website, you can get all the resume formats for freshers, on L2 experience in networking, in Microsoft, in software side, like any tracks, any department have a resume format. Is it? There's a website, and go to the last page, last here to home page. On the right side, popular page is on the right side. Resume objective. We click on it. So resume formats for sample seasonal resume skills, computer hardware, PC hardware, network administrator, CCNP, CCIE, MCSA, MCSE, Linux, IT support, web designer, C programmer, like all type of resume formats are available. For example, sample seasonal resume skills. You click on it. Here we have all the methods, like all type of number of samples is here. Here you can see roles and responsibilities. Don't do just copy and paste. Huh? Read the points and which point is suitable for you. Take the some few points from this resume. Okay, guys. Any more doubts? Try to practice on this both topologies. If you are facing any difficulties, you can text me in the WhatsApp. I'll try to solve them. Okay. So meet you on Monday by 2 o'clock, same time. Thank you. Thank you to all. I'm going to end the meeting now. Any queries? Sunil, any doubts? Sahil, Ram, Punit, Shiva, Mustafa, Ankita. Thank you. Okay. So thanks to all once again. Bye. See you. Meet you on Monday.